Hello everyone and welcome back to our SQL series. So we have done with select, we have done joins. Now we are going to take our queries on another level. And how? Subqueries. So subquery is a query inside a query. Sounds complicated, right? But it's not. Once you understand the pattern, it unlocks the whole new set of things which you can do on SQL. So today we are going to go through what is subquery, where you can use it, what are the locations of it, in versus exits, and correlated subqueries. So now let's go. Okay, so now let's start with what is subquery. So subquery is simply a select statement within another SQL statement. Okay, so look at the slide. The outer query is the main query, and inside it, which is wrapped with the parenthesis, the bracket, that is subquery, the inner query. So here is the key thing to understand. Okay, the subquery runs first, the result is calculated, and that result is passed to an outer query. So just think like you need to find the products which costs more than the average price of the product range. So but you don't know the average first, so what we will do in two steps, right? So step one will be what is the average price. Second one will be give me the product where the price is greater than average. It will be step two. So here step one will be the subquery and step two will be the outer query, right? First we will find the step one, the average price. So if you just see at the syntax first, so what are the rules we follow? One, it should be always, the subquery should be always wrapped in parenthesis. It should be in bracket, right? So it denotes that. Second one, the subquery runs before the outer query, as we discussed. And the third one, the subquery can go in where, select, from, or having. This is the location where subquery can lie. Okay. So the next one you can see is subquery location. So there are four places where subquery can go. So let me take through one of this quickly. Right. So first one is where. It is the most common one. It filters the row using subquery result. Second one is the select. It calculates the value per row using the subquery. Okay, just find the keywords where filters the rows. Select, calculate the rows, calculate the value from that rows per row. From, uses a subquery as a temporary table, like a derived table from a bigger table. We just derive the smaller one, that is from. And if it is in having, it filters the group having the subquery result. You will get to know it through the examples as well, and as you get a hands-on, you will just see it and feel it, right? So now let's switch to Workbench. You can see here, right? I have already written the code. What this code will give us, it will give us the products which are priced over all average. Okay, the product which are priced are expensive than overall average. Okay, simple statement. Now let's see the code. You can see we are going to select product name and price from the products where. Okay, now you can see subquery will start from here. Okay, where price is greater than what? We are selecting average of the price from product. Here select average from the product is the subquery. Where it comes where, in the where clause, right? So what where clause does, the most common one I just told you, right? It filters the rows using the subquery result. So what it will do, it will find, okay, where the price is greater than the subquery, and the subquery says average price. So what it will do, it will just find the average price from all the products, right? There will be the value, just assume the value as x. So what it will do now is, the code will be now internally select product name comma price from the products where price is greater than x. Okay, till now let's consider it as x. Then this code will run, then it will just order the price descendingly to get the top ones. And if you see the result of this, the output of this, you can see, we can clearly see these only are the products which are greater than the average price of the product range. You got it? We got it, right? Now if you just go through the another code, what this will do, it will just treat, okay, if you just see the code clearly, it will just treat this as a temporary table to get an output from the temporary table. So if you just see the code, select city comma total customers from, right? What from does, from just filters the rows to make use it as a temporary table, also called as derived table, right? If you see the from, you will just know, okay, the whole table is gonna form. What we are going to do, we are going to select count star as the total numbers. You know what count star does, it just makes a total of everything, right? From customer, city is not null, group it by city as a city summary. Okay, it will just select the number of customers which belong to the particular city, add them all, and just it will just mention, for example, I'll just, without running the code, I'll just tell you how can the output be. It will be like Pune 10 customers, Ahmedabad 15 customers, Mumbai 20 customers. It will just add up the value and mention there. Okay, this is what this code will do. And what we are going to do, we are going to use this table as another format table. The table will be known as city summary, which is derived table. Now this table, from this table, what we are going to select, we are going to select city and total customers, and we are going to order it descendingly, right? If you run this, you will get it, right? This is what from does. It just makes the another table, temporary table, and we use that temporary table to get our output. The next one which we are going to do is in and not in. Perfect one. Now let's go through this. If you see what in does checks if all the value matches any value in the list written by the subquery. If yes, the row will be included. If no, row will be not be included. It will just check whether the value is present. Yes, no, done. That's what in does in this subquery, right? If you just see the code, what this code will give us, this code will give us the customers who have placed an order at least once. At least once the order is placed, you will get that customer's detail, right? So what, let's see the code. Select first name comma last name from customers where customer id in. So you can see the keyword in here, right? In. Select distinct customer id from orders. So what it will do is it will just get the customer's id, distinct customer id, unique customer id from the order table, right? Now it will check whether that customer id are also in customers. If yes, then it will just give us the first name and last name of that customer, and we will get all the customers who have at least placed the order once. Now this, if we just need to find, okay, these are the customers who placed an order. What if we need the customers who never placed an order? In that case, not in will come in the picture, right? So same code, but if we just use not in there, we will get all the customers who have not placed a order single once, never placed an order, right? So instead of in, just not in, run the code, and you will get the customers who have never placed an order, right? And here is an important part, not a part but a warning about not in. If the subquery returns even one null value, not in returns no rows at all, zero result. It's not an error, it is zero result. The trips completely, people are badly. So what we need to do this, we will just fix this. And how? Always add is not null in the subquery when using not in. So what happens is, so where customer not in, right? So instead of that, you can also add, you should add where customer id is not null, right? So if there are not null result, then you will just get it instead of zero results. That was a small tip. You can add this, it will be useful to make an query understandable for yourself also, and also for your code reader, anyone, right? So next one is exists and non-exists. So exists one differently from in. So in fetches the entire list from the subquery, where then the check value for each one, right? Exists just ask, does the query return any rows? If yes, true. As soon as one match is found, it stops. That's why it is faster than the in for the larger set as well. So what it does, in will fetch all the values, then check all the values. It takes time, right? It is also used in some cases, but if you need to check whether the it exists or not in any rows, we will use exists, right? The word itself says it, right? So if you just see the code here, right, select cname dot c last name from customer c where exists, select one from the order 0 where order id is equals to customer c id, right? So what this code will give you, this code will give you customers who have placed order at least once, right? But using exists, right? So what this select one is, right? Why we are writing select one? What the select one does, select one is just a placeholder, right? It tells SQL I don't care if row exists, I don't know what that data contains. I only care if the row is present or no. I don't care about the data. That what select one the placeholder tells us, right? The subquery, I will tell you how this works, right? The subquery will check whether the at least one order exists in current customers, right? Then select one will come. The select one will check, okay, I only care whether the row exists or not. Okay, I don't care about the data, right? It will just count it as 1 2 3. Okay, if an order exist returns it is true, the customer is included, the count increases. Once we get all the data checked, it will just order it by customer name, sort it alphabetically A to Z, and that's it. We get an output, right? And we get all the customers who have placed at least one order, right? Now similarly we will check customers who have not, never, order, no orders, no single order, right? What this will do, similarly, instead of exist, just write not exist, and you will get a complete output. Same output, you will get a good result when you need to only check it exists or not, and not you not need to check any values. Then exist is the best example. You can just implement it, no doubt, right? There is a quick rule when to use this. Like use in when subquery returns a small list. When you have a small list, use in. When you have a large data set and you have to check the existence, just use exist. Use not exist instead of not in to avoid the null trap, right? Many of the cases I just discussed you, there is a null trap also. You just get null, not null, error. You don't understand whether it is error or no or exist. In that case, just use not exist and you will get the values. Even if, see, if you use not in, you will not see that row only itself. You will not get to know whether it is error or no data exists. If you use not exist, then you will see zero there, and that zero will make sure, okay, the customer has no orders. That's where the reason it has, right? So not exist is a good option there. So now we will move to correlated subqueries. So this is a advanced topic or advanced type of subquery. It is like a correlated subquery. So a regular subquery runs only once and it results it's reused, right? You will just write that as, if you just remember, we just mentioned it as order summary or something summary. You just mention it as some table and it can be reused many times, right? But the correlated subqueries are quite different. It refers as a column from the outer query, which means it runs once per row. Remember this, it runs once per row in the outer query. So if you just see this code comparison on my slide, look at the non-correlated query. Non-correlated query, it calculates average price once and reuses that number for every row, right? Just take average price, compare it every row, that's it. That was non-correlated query does. The inner query has no reference to the outer query. This is what it does. Okay, now if we look at correlated version of that query, the subquery says, okay, where o dot customer id is equals to c dot customer id, that is customer id from customer table, which is c dot customer id, comes from the outer query. So for example, so for Rahul, it runs the subquery with customer id 1. For Priya, it will run for as customer id 2. For customer A, it will run a new run. Okay, so not select the particular value for each row as like non-correlated, just take one value, just compare everything with each row. No, in correlated version, it will take particular id, it will just particular for particular row. That's the reason it is powerful, accurate is it, but it's slower. Why? Because it compares every row with a new format. That keep that in mind, right? That's the reason it's slower version for that. If you just see the workbench now, here is a classic example again. Each customer with a personal order count, right? So see the code, select c dot first name, c dot last name. Here select star count from orders o, where o dot customer id is equal to c dot customer id as total orders from customer c, order by total orders descendingly. Okay, so now if you remember the locations where subquery can exist or can go, we completed where, have, from, having the similar one. Now here comes, it is in select. The query is in select, right? So what it will do when it is exists in select? If you want, you can just go back to that point and see what is the location of subquery and what it does. So the select one calculate row per column. It will calculate a row per column using the subquery. The word per column, right? The correlated one. That's how we need to learn it. Okay, this subquery exists in select, then what it will do. If it exists in from, what it will do. Okay, it is in having, what it will do. That's the way we should know. Okay, now it in select, it will go row wise, right? So if you run this, it will show all the customers, even though with the zero orders. The subquery returns zero for them. It is very clean. It is the most powerful method to do it, right? If you just see this, you will get everything. The subquery runs once for each customers and counts how many order the customer has given. If you see Aditya, okay, one count, then Abhijit, one count, then again Aditya comes in picture, the count will go to two. It will just add upon, right? So the count is returned to a new table. What is the new table called? It is called as total orders, right? If you just see as total orders, right? The main query results each customer's name along with the total numbers of order he has placed, which we just got from our subquery. Then we will just order by the total orders count descendingly, and we will get the highest to lowest number of the orders, and that what this code gives us. And this is how correlated query runs, row by row, each value for the each row, right? So here is a recap what we learned in this whole video, the subquery one. Okay, you can see first one, subquery. Select inside another statement. What runs first? Result passed to outer query, right? Where it filters rows using subquery result. If it is in select, it calculate value per row. If it is in from, it will derive a table, use it as temporary table, and alias is must given thing to it, right? Alias must be given. If it is in having, it will just filter the group using subqueries. The things need to remember in the value in subquery list, watch null with not in. Okay, that's the important thing. Watch it. Exist, any row returns and it is faster on the larger data set. I will suggest use exist most of the time. Not exist, it is like a self safer alternative to not in. Not in makes a trap for the code. Don't use it. Mostly use it as not exist. Last one is correlated. It references outer query, runs per row, powerful but slower. I just told you how, right? So subquery unlocks a completely different way of thinking about the data. Instead of asking for data, you start composing the question inside the question subquery. Like in the next video, what we will do, we will just learn window functions. Window functions like rank, dense rank, row number, lead, and lag. 5 things. Okay. These functions that make SQL feel like it is a proper analytical tool. You can just analyze data this way to get a better results inside the Windows function. Must learn, must required in day-to-day life of data analyst or any data person who uses SQL. So stay tuned for it. Subscribe so you don't miss this, and see you in the next episode. Bye bye.